All right, here's a completed problem number 7. Is the area model to multiply these two polynomials. You can increase the size of this area model to reflect the size of your polynomial. In this case, it's a quadratic times a quadratic. Now, I'm using this example mainly just to point out a few things. One, the diagonals, which I highlighted in color, always are like terms. So we have our 25x to the fourth. It's its own like term, but you can't add it to anything else. There's no other x to the fourth terms. The x cubed terms are diagonal, the x squared terms are all diagonal, and the x terms are all diagonal. And 8 is its own term as the constant. Now the number of diagonals should reflect the exact number of terms in your final polynomial. And if you have a degree 4 polynomial, which we end up having here, then you will have 1, 2, 3, 4, 5 terms. The last term will be a constant and it won't have an exponent. Okay. Now we're going to use this to look at how to divide polynomials. So in this case, what it says is that we're going to divide this linear term into this larger degree 3 polynomial. So let's take a step back for 1 second and consider this. If we do 8 divided by 3, that's essentially saying, all right, I'm going to take 3 and I want to multiply it by something to go into 8. Well, I know it doesn't divide evenly, but I can multiply 3 twice, which will give me 6. And then if I remember how to do long division, then I'm going to have a remainder of 2. Sometimes there will be a remainder, sometimes there will not, as there will be with polynomial division. But you're looking for the two numbers that multiply together to give you 8. In this case, what you're looking for are two polynomials that multiply together to give you the greater polynomial of degree 3. So I know that x and negative 4 would have to be on one side. Now I don't know how big to make this table. What I do know from the previous multiplication example is that the number of diagonals that I have to match the number of terms that I have. And here I have 4 terms. It's a degree 3. So I need to make sure that here I'm going to have 1, and that will give me my 9x cubed. Here I'll have another, and that will give me my negative 44x squared. I can make another, and that'll give me my 28 times x. And then the last one will always be a constant, so it'll just be that bottom right rectangle. And that'll give me 16. So I don't necessarily need anything past that. Now to set this up, it's really just a puzzle and you have to fill in the blanks. What you do know already is that 9x cubed is the only term in the rectangle. There's no other like terms, and also 16 has to be there. So now you can start filling in the blanks. This will be 9x squared. That'll give me 9x cubed. And now I can work down. I can multiply here. Negative 36x squared. Now look at how many like terms I have to combine to get negative 44x squareds. Well, I have negative 36 already, so that means I have to have a negative 8x squareds to give me a total of that. So now x times what gives me negative 8x squared, and that's negative 8x. Now I can multiply down because I have the lengths of this rectangle, which would be a positive 32x. And now look, once again, I can find out how many like terms I need to combine in order to get 28x's. So that would be a negative 4x. And now I can jump back to the top and say x times what gives me negative 4x. That would be a negative 4. And just to check my final rectangle down here, negative 4 times negative 4 would be a positive 16. And it works. If it was anything other than an exact match to get 16, that means I'm going to have a remainder. Okay, and we'd have to deal with that a little bit different. So now to satisfy our results, we know that this division has an answer, and it's right there. We can also say that, just like our other problem over here, 3 times 2 plus something extra would give me 8. But in this case, I don't have a remainder. I know that x, subtract 4 times 9x squared, subtract 8x minus 4. That'll have to equal 9x cubed minus 44x squared plus 28x plus 16 with no remainder. Okay, so if you were to multiply these two polynomials back out, whether you were distributing or whether you're using the area model to multiply it back out, you would get exactly the polynomial you started with. And that's how to do long division using the area model and working backwards.